Okay, so Mariam set up an experiment as shown in the diagram below. Okay, so Mariam. So there is a retort stand. Both setups have a retort stand. Have a retort stand with a thermometer, holding a thermometer that is lowered into a beaker of tap water. The only difference between the two are the ice cubes. Okay, and a block of ice. The ice cube is uh, evenly spaced out, whereas in setup B, the entire beaker of water sits on the block of ice. So which one of the setup A or B will the temperature drop faster after a few minutes? Okay, so think about it before I give you the answer. Setup A has ice cubes which are evenly spaced out, whereas setup B has a block of ice and the entire beaker sits on it. Well, the answer is quite obvious, but let's just check. Okay, uh, let me see whether I can do this. Okay, so uh, the answer is B because why is this so? Because uh, the ice cubes is spaced out. So there are some points of contact. I'm going to use a line. I'm going to use a pen to show you that there's some parts of it are in contact with the ice, whereas some are not in contact with the ice. There are spaces. So there are places underneath the beaker which are not in contact with the ice. Whereas the block of ice, the entire base is touching the beaker. So there are more ice touching the beaker in setup B than setup A. So the answer here would be B because the water is exposed to a larger contact area of the ice. Okay. Therefore, the heat loss from the water will be faster because if if there is heat, right? From because there is heat in the water, it can only escape at the points where the ice is touching the beaker, okay, in this particular case. Whereas over here, this entire surface can be used, heat from the beaker will be escaping, uh, will be transferred from the warmer water to the colder ice throughout the entire base of the beaker. Okay, now surface area plays a very important factor when it comes to heat transfer. Okay, the more surface area, the easier for the heat to be transferred. Next, Mariam's mother asked her to prepare some ice. She used 800 cubic centimeter to make ice cubes and another 800 cubic centimeter to make ice blocks. Which type of ice cubes or blocks should she put in the cooler so that the drink is chilled as quickly as possible? Again, imagine you're putting the entire ice here into the cooler, okay? And so if you put the ice blocks into the cooler, you put the ice cubes into the cooler, which one do you think has more surface area? Okay, the ice blocks has water is able to go all around them in between the different pieces of the ice blocks. Whereas for the ice cubes, sorry, not the ice blocks, for the ice cubes, the heat is able to surround the ice cubes, right? Because there's more surface here, all right? Whereas for the ice blocks, uh, there's more surface. Uh, there are only a few surfaces. There's 1, 2, 3, and 4, 5, 6, 7, and 8, right? So there are, because it's equal amount, the answer should be the ice cubes because the ice cubes is the same amount of ice, but it has more surface area because, in between those parts, there the breaks in between the ice cube also allows the heat to enter. Okay, so what type of ice cubes? Okay, the answer would which type of ice allows the what drink to be chilled as quickly as possible? The answer would be the ice cubes. When you place the ice cubes in water, there'll be more surface area because the ice cubes can be surrounded by heat. Whereas over here, the heat is only transferred from the water through the contact area. And in this case, the contact surfaces, there's more in the block of ice than the ice cube. Okay, so this question really tests whether you can tell, whether you can differentiate, different shapes of the ice, and imagine, okay, or visualize the and compare which shape has a greater surface area. Okay, so in this case, the greater surface area, uh, in the first setup, the greater surface area in contact with heat is the ice, is the block of ice. And in the second part of the question, the greater surface area is uh, in contact with the whole entire water, uh, would be the ice cubes because all the cubes will be in water. Whereas here is only a bit. Alright, so if you do not understand what I just explained, maybe you would like to replay the video one more time, pause at the necessary uh, parts of the question so that you can try to understand the question better. Okay? If not, I'll explain this again in class. Thank you.